Okay, guys, so the purpose of this lesson is to break down a free response question from an AP test, kind of in its many parts. Believe this has as A, B, C, D, and it's involving rates in and rates out. So here's the example. Water is pumped into an underground tank at a constant rate of 8 gallons per minute, but also at the same time, water is leaking out of the tank at a rate of root T plus 1 gallons per minute, and that's between 0 and 120 minutes. Then it tells you at time 0, the tank contains 30 gallons of water. So that's like when it started, it already had 30 gallons in it. So again, we're going to break this down into like a bunch of different parts. So we're going to start with water, just the fact that water is being pumped into the tank at a constant rate of 8 gallons per minute is really the rate they give us. So it says how much water is pumped into the tank in the first 3 minutes. Well, this is an easier calculus problem because it doesn't change. It's constant. So if it's doing 8 gallons per minute and we did 3 minutes, 3 minutes times 8 gallons per minute. Kind of nice here that the minutes just cancel and you get 24, and the only units that you have left are gallons. So that's kind of nice. I would approach this with the units thing. It kind of solidifies your answer as you know you're doing it right. The next one, write a function that represents the amount of water pumped into the tank at any time in the first T minutes. So you want more of a function here. So let's name our function. I don't know. Let's call it G of T gallons at any time. And we just want to know how much is being pumped into the tank. So again, only that first sentence of this problem are we looking at, and it's 8 gallons per minute. So there you go. We got a function that you take 8 and you multiply by however many minutes there are, and it'll always tell you how many gallons were pumped into the tank. Part C, assuming that no water is leaking out from the tank, write an expression for the total amount of water in the tank after T minutes. So we already have an expression that tells us how much water was pumped into the tank. The only other thing that we need to take into consideration is that there were 30 gallons to start. So in this case, we have 30 gallons to start plus the amount that came in at any time, which we don't know. So again, the rate in was 8 gallons per minute. So we have to, in this case, we actually take into consideration the initial value, and that part is actually the part that we have trouble, we forget that, and that's a big part of the AP test. So let's break down this even further. Suppose water is pumped into the tank, a different tank, and starting at time 0 at a rate of 12 gallons per minute. They're telling you that at time 17 minutes, there are 439 gallons of water in the tank. Write an expression for the total amount of water in the tank. So we can actually do this kind of similar to the last one, but this problem doesn't tell you how much is in the tank to start. They just tell you at time 0, that's when time starts, that the rate is a constant rate, this time at 12 gallons per minute. So I did some kind of like taking advantage of what we just did. I did some math and I said, well, if we do 12 gallons, right, times 17 minutes, that'll tell us how many gallons were pumped into the tank during those 17 minutes, and that's only 204. So that's pumped in. So if there are 439 gallons at 17 minutes, then you just do some subtraction, and the starting amount is 235, if I'm correct. So we could do something similar to that green equation there, and we can say, okay, well then G of T would be the starting amount, which we calculated to be 235, plus the rate in, 12 this time, times any time. And that is an equation that will tell us any time how many gallons are in this tank of water, or in this tank being filled up with water. So there's a few ways to go about this. I like that one. It's very logical. I think a slightly easier approach is this is actually an ordered pair. They're saying at this time, there's this many gallons. So, and we actually already know the rate, in other words, the slope. So we can literally just take point slope form. So y, number of gallons, minus y1, so that happens to be a point we know, equals the slope, or the rate, 12, times, let's call it t, minus the time we know. And if you were to calculate that out, it would actually be in slope-intercept form. It would look like that green one. But that's just point slope form, and it works out really nice because there's not many calculations that have to be done. You just plug in the numbers. So that's a good one. And then now, getting on to the calculus. The calculus way is the way you'll probably end up using in a lot of your problems. When they give you a value to start with, you usually use that as like your initial amount. So weirdly, they give you a time at time 17. There's 439. That's not really like a start, right? It's kind of like in the middle, but it is a value that they gave you. It's like an initial condition. So one thing I want to highlight at the top of this page, it says integrate a rate and you get an amount. So let's focus there first. If you integrate the rate, 12t, or actually, sorry, it's a constant rate. So if you integrate 12, you actually get the rate, how much water is being pumped in. So you need a starting time. Well, I know this thing starts at time 0. I get that. But if you put 17 down here as your starting time, then you can put, at that time, we started with 439. So that's like an initial value. At time 17 when you started, there were 439 gallons in, and you're integrating that from 17 to some unknown time whenever we want to stop. So that actually is a really good one. There's also a way that we have to do a little bit of calculations. If you think all the way back over here, we figured out our starting amount at time 0. So if you like that, at time 0, if you start at time 0, you have an initial value of 235 and goes to time t. And again, the rate is 12. It's a constant rate. So that's another representation to find the amount of water in the tank at any time you want. That one is the one that people tend to like because starting is at time 0. But any one of these is actually a really good representation of what's in the tank. So moving on to a different part of the AP question. For this part, it says how many gallons of water leaked out of the tank from time 0 to time 3. So what we're going to do is we're going to first write an integral expression to represent the amount leaked out. And again, I'm going to highlight amount. So to get an amount, you have to integrate a rate. So I think for this one, we'll use the part that they gave us up at the top. It says water leaks out at a rate of this. Okay, so that's our rate. Let's integrate it. So we're going to integrate the square root of t plus 1. And it said write an integral expression. So I believe they wanted from 0 to 3. So that's what we would have. And then it's part B says, okay, let's go ahead and integrate this. So in order to integrate it, this is a chain rule technically. So you're going to need a little u sub, and then du is just dt. So technically what we have is the square root of u, but I'm going to rewrite that u to the 1/2, and that will go to u to the 3/2 times 2/3. And we need to evaluate that. Sorry, from 0 to 3, but before I do that, I'm going to plug my u back in. 2/3 t plus 1 to the 3/2 evaluated from 0 to 3. So I tell people to go ahead and do your parentheses. Now if you plug in 3, you get 4 inside the parentheses, so 2/3 times 4 to the 3/2. And if you plug in 0, you get 1 to the 3/2 on the inside. That's just 1. So this is ended up being just 2/3. And to evaluate 4 to the 3/2 without a calculator, I would do the square root part first. So 4, square root of 4 is 2. 2 to the 3rd now is 8. So I've got 2/3 times 8 minus 2/3. Quickly, that's 16 thirds minus 2/3, so we've got, 14/3 as a final answer. Okay, so that was evaluating how much water leaked out of the tank, right? So now it says how much water leaks from the tank between time 3 and time 8. So now we just have to basically repeat the same process, but do this from 3 to 8. So I'm gonna go ahead and jump all the way. It's basically this part right here, and we have 2/3 t plus 1 to the 3/2 from 3 to 8, and then just do these calculations. And again, you could probably do this pretty quickly, but 2/3 times 9 to the 3/2 minus, that's plugging in 8, by the way. If you plug in 3, you get 4, so 2/3 times 4 to the 3/2. All right, same process. I would take the square root of 9 first, so that's 3. 3 cubed is 27. 27 times 2/3 is 54/3. And just doing that quickly because you guys can do these calculations. 4, do the next part. 4 square root of that is 2. 2 cubed, actually we already did all that. That's actually 16/3. You saw that right above. And then do the subtraction there, and I believe we get 38/3. And in both those answers there, it says how much water. So our unit should be gallons. What we just found twice was how much water leaked out of the tank during those times. Okay, moving on to the next parts. So the next one says how many gallons of water are in the tank at time 3. So this is important. We have 3 parts always to this. You have 30 gallons to start, and that's very important. A lot of people forget about the starting amount. And then how much water came into the tank between 0 and 3 minutes. Well, that, if you recall, goes all the way back here to part A. It says how much water was pumped into the tank between 0 and 3. That's 24 gallons. So we can add 24, and I'll call that in, and we're going to subtract the water that leaked out, which we just found to be between 0 and 3 now. That's the red one up there. That's 14/3. So you're always going to have a starting amount. If you got a rate in, rate out problem, you're going to add the rate that came in, subtract the rate that came out, and doing the quick math there, that is how many gallons are in the tank total at time 3. All right, now kind of more moving on to a different part of this question. It says write an expression, let's call it A of t, for the total amount of gallons at any time. So in order to do that, let's first find the rate at which the amount of water is changing. So in order to do that, let's call that just rate for now. We need to have rate in is 8, so that's a positive 8 because there's 8 gallons per minute coming in. And we're going to subtract the rate that's going out, which was just square root of t plus 1. So that is all about rates. Those are the derivatives, right? The rates. So if we want the total number of gallons of water, well, that's the amount. So we basically integrate those two things. Now, so integrate this. Now, if you set that up, there's no limits on the integral. That's not good. We need to have limits. So we need to set a starting amount and or starting time, I should say. So let's start at time 0, which is logical, but you have to ask yourself, is there any water in the tank at time 0? And the question is yes, or the answer is yes. We had 30 to start. We don't know when we were stopping. Let's call that x. So we just set up an equation. Technically, this upper limit should be t, and this should be x, but you get the idea. So this is the idea. You're integrating a rate, so this will tell you the amount of water, the change, rate in, rate out, right? That'll tell you how much water changed. We might have lost some water, we might have gained some water. But we definitely started with 30. So that'll tell you at any time you want. All right, and to finish it up, part D in the AP question says, at what time is the amount of water in the tank at a maximum? So there is quite a bit behind this. Now we're trying to find the maximum of the amount of water. So this tells you the amount of water in the tank. Well, if you want to find the maximum of that, you need to find the derivative of that, right? So what calculus is behind finding an extreme value? Well, you got to take the derivative, or have the derivative, and then find the critical values. And just to recall, critical values are when the first derivative would equal 0 or undefined. And then finally, this says when is the maximum. So we probably want the highest point, which makes it an absolute maximum. So we need to test the y values at each one of those critical points, and I have to add in here, and endpoints. When you do absolutes, you need to remember to test endpoints. That's what a lot of people forget. So critical values, that's part B here. Critical values, in order to find them, we need to take the derivative. So if you take the derivative of that equation, well, derivative of 30 is just a constant, so that actually is gone. And if you take the derivative of that integral up top, the derivative of this integral, hopefully this looks familiar. Well, that's a second fundamental theorem of calculus. Tells you to take that upper limit and plug it in. So you're going to have 8 minus square root of t plus 1. And technically you should multiply by the derivative of t, which is 1. So that is actually our derivative, our a prime, I should say. So now we want to set, first of all, that'll never be undefined, right? So that's one thing. But will it ever equal 0? So 0 equals 8 minus the square root of t plus 1. I might add over that t plus 1 to square both sides, and then subtract 1. So it appears at 63 we have a critical value. So that would be our critical value for this question. So now it says the final one, which is basically how do you do this, is you want to find the y value. That's what I meant by y value here. Find the y value of the function at the endpoints and critical values. So I call this the candidates test. So there are 3 candidates. Well, we started at time 0. We found a critical value in the middle at 63, and then our endpoint is 120 seconds. We need to find basically what the A value is at each one of those. And don't forget, our A equation is up here. So at time 0, they actually gave you that in the initial part of the problem. There's the amount of water in the tank is 30. So at 63, what you would do is plug in 63 for your time. And I apologize if I haven't shown you how to do a definite integral in your calculator yet, but I would definitely do that when I return. For now, you guys can set these up, and I'll this is one where I'd probably want you to actually do in a calculator to test these, because there's there's going to be a couple of them. So this one is 193.3 repeating. That's the amount of water in the tank at that time, and then do the same thing with 120. Remember, again, I'm going to show you how to do this if I haven't already in a calculator. And in this, when you put 120, you get 103.3 repeating. So the question again was to find a maximum way up here. Well, that would happen at, so A of t has a max at time equals 63. And by all this work here, this is definitely justification, but what you say is by the candidates test, and that basically says that what you just did. I tested all the candidates, all the possible max or mins, and whichever those are the only ones that can have the max or min, so the highest one is obviously the max. So I hope that works. Feel free to watch this again if you